Okay, so today we're going to solve a system of equations using the graphing method. And as we did when the equations were in slope-intercept form, we're going to graph our two lines that we have, see where they intersect. The only difference in this one is the equations are now in standard form instead of slope-intercept form. But do not be scared. It's not that much crazier. We knew how to figure these out when they were in slope-intercept form. Just graph the lines, find out where they intersect. Life is good. So now what we're going to do is take these, put them in slope-intercept form, and then just follow the same method that we did before. Most of us struggle with converting these into slope-intercept form, so make sure you practice it. Go back to earlier videos if you need help. We'll be good to go. Now I'm good. I have different colors, so it's a lot easier for me. But to be organized, usually what I like to do, we'll call this number 1, and that number 2, and then we'll just be organized with our work. So again, I'm going to turn this from standard form into slope-intercept form. So let's start off with number 1, 3x plus 2y equals -4. You're solving for y, so you have to get y by itself. Get rid of the 3x first. Subtract 3x. Subtract 3x. 2y equals, you could do -4 minus 3x, but remember slope-intercept form is y equals mx plus b, so you want the x term first. So I'm just going to write it like this instead. Remember, didn't violate any math laws there. Divide by 2. Should we divide everything by 2? So y equals 2x minus 2. Okay. And I'll graph it in a minute. Let's get the blue one in slope-intercept form too. So x minus 2y equals -4. Solve for y, subtract x. -2y equals, don't forget that negative sign with 2y. Then again, I'm going to just rearrange the way I write that. Divide by -2. So y equals -x divided by -2. Well, the negatives become a positive, and that's a 1/2 x plus 2. Again, as I said, if you struggle with things like this, make sure you're getting help by the earlier videos. Okay, now let's graph each of these. I'll start off with pink. Start off with your y-intercept, go down 2. Remember when you have a negative slope, you would like this. It's either -3/2 or 3 over, that's a 2, -2. Okay, that's what that negative slope tells us. And slope's the difference in y over your difference in x. So I'll go with the first one. Difference in y is 3, so go down 3. 1, 2, 3 over 2, 1, 2. And then you can go up 1, 2, 3 over 2. Okay, there's the pink one. Okay, now with the blue, y-intercept is 0, 2. Slope's 1 over 2, so I go up 1 over 2. Down 1 over 2. Okay. Now remember, we're looking for the intersection points. Oh, look at that. Right there. The coordinates on that guy, -2, 1. So that's our answer. But, Mr. Pons, what does that mean? Great question. Remember, this ordered pair is the only ordered pair that works for the pink and the blue at the same time. And if you think about that geometrically, that's where your two lines are intersecting. So whenever you have a system and they're trying to tell you to find the solution of the system, you're looking for that intersection point. Whether it's lines, parabolas, absolute value, whatever it is, you're looking for that intersection point. So always keep that in the back of your head. And remember that that ordered pair works for this one and at the same time works for that one. Try it out. Okay, let's try one more example together. Okay. Okay, and I would suggest maybe doing this one by yourself, pausing the video, and then coming back and seeing if you got the right answer. Okay. So you have 2x minus 3y equals 3, and 2x plus 3y equals 9. So again, pause the video, try it out yourself, and then come back. Okay, welcome back. Or if you never left, hello. Okay, so again, I'm going to break this off again, get these in slope-intercept form so they're easier to graph. So we'll first work on the first one. 2x minus 3y equals 3. We're solving for y, so I've got to get rid of 2x first. Don't forget the negative sign. Negative 3y equals, remember I'm just going to switch the order of the terms so it's easier to graph. Don't forget that negative sign. Divide by negative 3. So you get y equals 2/3 x minus 1. Now let's do the same thing for the other one. Put that one in blue. X plus 3y equals 9. Solve for y. 3y equals negative 2x plus 9. Divide by 3. So y equals negative 2/3 x plus 3. And now I can graph each one of these. Start off with pink. Go down 1. Slope's 2/3, so your difference in y is 2, 1, 2. Difference in x is 3, 1, 2, 3. Or you could go down 2 over 3, 1, 2, 3. Over a negative gives you a positive. Okay, now I can graph this one. Go up 3, then negative 2/3. Remember, it's either this or that when you're graphing. So I could go down 2, 1, 2, 1, 2, 3. Or I could go up 2, 1, 2, 1, 2, 3. Okay, hopefully this makes sense to you. Okay, now we look for that intersection point. Oh, look at that. He's screaming out your name. Right there. Coordinates on that, negative 3,1. And again, you should be asking yourself, Mr. Pons, what does that mean? You should be able to answer it. Not only is that where these two lines intersect, but that's the only ordered pair that works for both of these. Okay. So again, this is how we solve systems by graphing. We're going to learn more efficient ways, especially for one like this, here pretty shortly. But at least have it in the back of your mind as you move on in this chapter that we're looking for that intersection point. And that's the only point that works for both of those equations. Okay?